Hi, everybody. Let the record reflect. No, I'm not going to do that today. I am going to do Oh Hi Mark again. That's pretty clear. All right, we're going to start out this video, this construction by, this is, by the way, the angle bisector video. Angle bisector is a line or array that cuts an angle into two equal parts. So what we're going to do is we're going to do two of them. And each one that we do, I feel like the focus is not as good as I want it to be. Let's see. Yeesh. We're going to do two angles in this angle bisector video. And the first one that we're going to do is just a regular old acute angle. So I'm asking my friends here at school to draw just any acute angle. Acute means less than 90 degrees. Or acute is a word used to define me. Oh boy. Oh, I am something else. The last construction, like I said, is a lot more steps than this because we were asked to recreate that picture. With an angle bisector, all I'm doing is just drawing a line down the middle using the power of mathematics. Take the stabby end of your compass. Okay? And put it on the vertex of the angle. In this case, it doesn't really matter how long the measurement of the compass is, as long as the line you draw is shorter than both angle sides. And you're literally just going to draw a curve that hits both sides. I think what I said in the previous construction is sometimes it's just not a bad idea to move the paper and hold the compass still. I think you'll find out that you're more likely to not screw up if you do it that way. Okay, so I have an angle with a nice arc hitting both sides. You don't need to adjust your compass, although you can, but you don't. You take each intersection that you make, put the stabby end at one of them, and draw a curve at where you think like the middle of the lines would be. Make a mark. No. Make a mark. And then go to the other, take your stabby end and go to the other intersection here. I can't see. Why am I struggling with this? I'm just so nervous. Make a mark. And now we have an intersection of the two marks. And, huh? Oh, hi, Mark. Let the record reflect that the kids are laughing uncontrollably at my oh, hi, Mark joke. And they laugh as if it's the first time they hear it every single time. Thank you, kids. I'm going to take a line connecting the vertex to the curvy X-looking thing, and that's my angle bisector. That's my angle bisector. I'm not happy with the fact that my line isn't perfectly on the vertex, but the idea is there. I mean, we can accurately say that, yeah, it looks like that line cuts that angle in half. So it is well. It is well. Let's do another one. No. Yes, says the crowd. I'm just going to leave that up there, let it marinate for a second. If I turn this over, is it? Nah. Let me get a new piece of paper. I feel like I should keep the papers that I use to make these things so that when I do hit it big on YouTube, like people can be like, wow, that's the actual paper that Nick Perich used to make these constructions. I'll buy that off of eBay for $100,000.
Can you believe people actually do that?
No, not for me. Not for me. Although I don't get it. Like the people that do get like tens of thousands of views on these videos make like such. They don't even make jokes, and yet people are like, "Oh, just watch this boring guy," and not the handsome, cool guy that makes silly jokes about Marx. Marxism. It's a type of government. Make yourself a obtuse angle. Where's my Sharpie? All right, make yourself an obtuse angle just so we can show that the thing that we're doing works for both acute and obtuse angles. You know, just trying to prove a point here, which is punny but not meant to be. Here's my obtuse angle. Now, when we do these, in the last problem, I made a point that, like, I said we didn't have to adjust our compass. We might have to here. It's just dependent on the problem that we have or the picture that we draw. Step number 1, take my stabby end and put it on the vertex and do what? Do a mark that covers what? Both. Good. And like I said, get used to moving the paper instead of moving the compass. I feel like I don't screw up when I do it that way. And if you're like, I'm using a notebook, it's not as easy, I understand, and that's perfectly fine. I just know that I'm not an artist and I have to adjust. Now, what makes this problem different from the last problem is in the last problem, when I got to this point in the graph or in the construction, I said, don't adjust your compass. You don't have to. I might have to here because I take it back. I don't think I have to. Watch. I'm still going to keep that rule. I'm going to take my stabby end, go to the intersection right here, and make a mark where I feel would be the center of the angle. And so it's not going to look as amazing as the last one did, but it'll still work. Oh, hi, Mark. Never. Oh. And then I'm going to go over here and do the same thing. Look at that. It worked. It does look like a bubble. Thank you. Yes. Yes. It doesn't look like, let the record reflect. It doesn't look like a bubble at all. I sound like what now? Now what? Now what? Draw the line from the original vertex to the double X or the single X, whatever you want to call it. And even though the X happened inside the bubble, it still works. I mean, it still is going to be a ray in this case that cuts this angle into 2 equal parts. So, you know, not the most beautiful picture, but it still works. Constructions! I'm sorry, I just get so excited that I feel like I have to sing it from the mountaintops.
That was yellow.
Why do you guys do this to me?
You do this to yourself.
Like, all I get is like rudeness and
Can you get candy now?
yeah.
Oh, yeah.
All right, that's my those are angle bisectors, 2 of them, one obtuse, one acute. Bye.